Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. And just a quick word from our sponsor. FusionAuth provides authentication, authorization, and user management for any app. Deploy anywhere, integrate with anything in minutes. For a limited time, get 25% off for 12 months with promo code CynicalDev. Learn more at fusionauth.io/podcast. In this episode, we talk about Cassandra 4 with Patrick McFadin. Patrick is one of the leading experts of Apache Cassandra and data modeling techniques. As a chief evangelist for Apache Cassandra and consultant for DataStax, he has helped build some of the largest and exciting deployments in production. Previous to DataStax, he was a chief architect at Hobson's and an Oracle DBA/developer for over 15 years. So welcome to the Cynical Developer, Patrick.
Thanks, James. That was a great intro. Thank you.
Yeah, thank you for coming on and talking to us about this. Now, I did quite a few episodes about databases last year from Percona Live, and we were hoping to probably have a chat at Percona maybe this year, but due to current situation worldwide that we can't name due to fake news filtering, we've not been able to do it, so we're doing it the old-fashioned way, just remotely.
Yeah, it's too bad because I love Percona. It's like all the database nerds gathering in one place. Peter's done a really good job of finding all his friends who get into it.
Yeah. I'm not a database person, but I went to the Amsterdam event last year, and it was really, really good. I learned a lot from it. And I picked up and started working with Postgres off the back of it. So even as a podcast host, I'm learning a lot from these sort of talks and these events. And it's nice to see, because I'm a .NET developer. So just by pure nature, I'm dragged to go and start looking at Microsoft products, sort of SQL Server type things for databases.
Yeah, I mean, right now, if you're a Microsoft developer, you're probably picking up all the Azure tools as well. And, I can't fault it. I mean, Microsoft has done a really good job of creating a nice ecosystem. So they give you that obviousness. Like, why wouldn't you use it? It's all integrated into Visual Studio.
Yeah, and I don't use Visual Studio as such anymore. I'm a bit of a JetBrains fanboy, so I use DataGrip and Rider for most of my work.
That's pretty unusual for a Microsoft developer not using Visual Studio.
Yeah. It turns a few heads when I go into new clients, especially if they've got an existing development team and I'm coming in and slotting in with that team and helping push them forward. And they're like, right, so do you need a license for this? This is how we do it. I was like, no, this is what I'll be using. Thank you very much. It's faster.
Yeah, well, at least we didn't have an argument over VI versus Emacs. So
yeah. See, that's a whole nother level. I don't even know anything about that. I gave a couple of my friends who use Vim a lot. I gave them a hard time over it because from the outside looking in, it just looks so much like hard work. I don't bother.
Yeah, well, that's the old joke about Emacs. It's an operating system. No, it's an editor. No, it's both.
Yeah. And it's all about Azure and things like that. And sort of my experience with NoSQL implementations is very limited. And at the moment, we're using Cosmos and using that with the MongoDB API. And that's working quite well. Although I've had a battle with some of the other developers because they are very much SQL Server to the core. And they're like, well, there's a SQL Server API. I was like, yeah, the hint there was API. It's still the same back end.
Yeah, Cosmos. I think they did a really interesting job with Cosmos. They created this, that underlying infrastructure that will API anything. And it's really, Cosmos really is a storage engine at its base. That was the whole point of it. And then you could just run anything on top of it. I get where people get a little nervous about it because it isn't the fastest solution you can pick for sure, because there's a lot of translations. But if you're going to use SQL, then don't use the API. Just go use Microsoft SQL like native.
Yeah. And for what we were doing, we didn't need the relational database. We've got one big blob of data that's sort of like a God object that gets thrown around the system. And it's just, well, we're going to use it for the lifetime. We're going to use it. And after that, as a platform, we don't care about it because we take data in, we do stuff to it, we spit it out the other end, and somebody else deals with it, and we never touch it again. So it's only ever sat in our system as an historical record. So it just made sense to store it as a JSON document and be done with it.
Yeah, James, you're touching on probably the last 10 years of my career where I pretty much was like, you don't need every bell and whistle of a database to do what you're trying to do at scale. Yeah. And, I think that's a nice, what would be the word? The rational point of doing development now is like when you realize, oh, I don't need to bring in the Ferrari when I'm going to the store.
Yeah. It's one of my new favorite phrases is good enough is good enough. I don't need to do everything and be everything to every man. I just need to do what's needed. And that's where these sort of databases come in. Yeah. So rather than every other database technology that we've mentioned in the last 5 minutes, we're here to actually talk about Cassandra. So for the listeners who are not familiar with Cassandra, could you give us an overview? What is Cassandra?
What is Cassandra? Here, let's just one more database for you to add. But this is the database you should have, I believe, because so Cassandra is a NoSQL database. It was started at Facebook. I think that's the famous folklore is it was started at Facebook by a couple of the guys that worked on the original Dynamo paper, which is I would say probably one of the most seminal texts on how to do scale distributed databases that we've had. The Dynamo paper was the beginning of a lot of different databases and a lot of different methodologies. So, and that was around 2008, 2009. But Cassandra is really built on some core concepts, which is like replication is first-class citizen. That's how it works. It's a shared nothing architecture, so it's completely distributed, and the data model is familiar enough where if you look at Cassandra from a programmer standpoint, it looks like tables and rows, but it actually stores data in a very unique and simple way where it distributes your data very cleanly, and it's just not something the developer really needs to worry about, which is great. Some of the things that has made it a super popular database is it's the way that it manages uptime. It's really hard to bring down a Cassandra cluster, and how it scales. If you need more, you just add more. It doesn't really need downtime. And, that's why it's been a choice for some of the biggest infrastructure plays in the past 10 years. And it's just got that combination of things that you aren't going to get somewhere else. So yes, there are trade-offs in every database, but the trade-offs that it has are way biased more towards uptime and scale and distribution, and less around more of a full-featured like analytic database or something like that. So, and it's an Apache project. That's another thing that's really probably the most popular Apache project, one of the most popular Apache projects out there. If you look at any top database list, it's the only Apache database on there, which is pretty crazy, but it's completely an open source. So what you want to look at, it's out there. It's just download. You can do a git pull and check it out. But yeah, I mean, it is the database of the future as well. I mean, we're just getting started. We went past our 10-year mark. Probably the most stable database you can get right now. And yeah, let's talk about the future too. But yeah, NoSQL database.
Sure. So you said that it's a NoSQL database. What does NoSQL actually mean? Because it's a misconception, isn't it?
It is a bit. And the irony is that the NoSQL term was actually started by a Cassandra committer.
Right.
And it was at Berlin Buzzwords. Eric was up there talking about, hey, he had this SQL with a slash through it. He's like, we don't need that anymore. It's like Declaration of Independence from SQL. And ironically enough, Eric came up with a CQL spec. So anyway, there's a lot of irony in technology. This is just one of them. But what NoSQL means is it's non-relational. So you have plenty of relational databases out there: MySQL, Oracle, Postgres, SQL Server, you name it. Those are relational databases, meaning that they follow normalized data forms. So tables, joins, that sort of thing. NoSQL databases are kind of this mush of, well, everything else. But unfortunately, and this is one thing that's really, we've never really figured out how to categorize properly. It could be anything from a key value database to a document store to a column based database like Cassandra. Really what it means is you're not going to do joins probably. And it just is a different type of database. So immediately, if you're going to start using NoSQL, you have a learning curve.
Sure. Yeah, it's one of those misnomer names. NoSQL, but there is a query language.
Yeah, there is a query language.
Yeah, it's is it serverless? But there are servers. So yeah,
exactly.
It's keeping it on trend.
where does this run? Or it runs on the edge? No, it runs on a server that's farther away.
Yeah. So that's that NoSQL having a query language. I guess it's we briefly touched on it there, but does Cassandra have its own query language to be able to retrieve the data?
Yeah. So like I mentioned, we have the Cassandra query language, which is pretty SQL like. It's you do a select from where, and it's almost too familiar because it makes people get tripped up a bit. I teach a lot of people about data modeling, and part of it is like, how to use SQL properly and not think that it's SQL. But query language is pretty functional because it allows. It does things that programmers need, which is when you select, you can select the columns that you want. It's fully typed, so you have a typed schema. It's not just throw your data in the database and let it figure it out. Index whatever, the JavaScript of databases. Sorry, I'm not a big JavaScript fan. Why is 1 + A = true? Why?
Yeah.
We could be friends, but that just bothers me. But the whole idea of type schema is really important for anyone who's building to go on that round. I love TypeScript now because it finally puts types around JavaScript. But when you're building your application, having type is really important. But that Cassandra query language has a little with the where clause, there's a little bit more to learn there because that partitioning is really important. When you're building queries, you have to think, I could be potentially querying thousands of nodes of data. And that where clause is really important in that regard. But that's really the biggest thing you have to learn in Cassandra data modeling is how to use a primary key. But when you do, it's super powerful. You really just don't have any limits at that point.
Sure. So you mentioned there that there's a schema in there, which from my experience of NoSQL databases is somewhat different. Correct me if I'm wrong, but normally it is a case of, well, here's my object, go and stick it in the table and you deal with it and just give it me back when I ask for it.
Yeah, I'm going to blame Mongo for that. They created this whole world of like, give us your JSON, we'll give you a database. And that started the whole schemaless thing, which sure, I mean, that's useful for a lot of things. I'm not going to say no to that. And we may be actually seeing that come to Cassandra soon. Oh, you may have heard that here first. But it's exclusive. James, it happened here first. So you have to embargo this one now. No, it's open source. We can do whatever we want. But yeah, the idea of schema is so critical because, like I was saying, you don't want to have like the type system inside Cassandra is really, it's rich. It has a lot of types. Like we have an IP address type. So, you don't want to hand it like a domain name when you're looking for an IP address. You want that data to get marshaled properly and you want it to get rejected.
Yeah. Yeah, it sounds really good. And some of the things that I don't like about the Mongo implementation that I've been playing with is that when you come to query the information from the database, the query language is just so unwieldy because you're having to unbox and box stuff and things like that. In the end, it's just a case of, well, actually, I'll just go back to my app. I'll write a unit test that connects to the database. That's bad practice. Just show me what was in that record. Right? Yeah, that's fine. Yeah, I did what it was supposed to do.
When you're doing type testing and not duck typing in your code, yeah, you should stop.
Yeah. It's not stuff that makes it through to the live stuff, but it's also me being lazy. Because what I should do is actually go away and learn that syntax properly.
Well, and DBAs around the world will always rejoice when there's type because the DBA's job is to block developers from doing anything, really. So this is a good helper.
Yeah. I'm a big fan of strongly typed stuff as well because what you should and shouldn't be getting returned, and there's not as many gotchas down the road then.
Well, there's security issues. I mean, having a lack of type brings up really weird security things, or worse, Heisenbugs that you never thought of. Like, well, everyone knows that this is a number until it gets passed down to a microservice that isn't expecting that, and or someone throws in a string and everyone's fine with it until that one service pops, and you're like, "Why did that happen?" Oh,
yeah, I can neither deny nor confirm that I may have come across that recently.
It's like, I think I just proved that I've put a lot of terrible code in production.
Yeah. Well, that's pretty much, I've made a career out of doing that. It's what I do.
It's a very successful career of making horrible code.
Yeah. So some of the key features of Cassandra that are sort of touted on the website are fault tolerance, it's decentralized, and that it's durable. And I just wanted to sort of touch on those. Now, the biggest one to start with that jumps out to me is it's fault tolerant. How can a database be fault tolerant? Surely it just deals with, here's some data and you put it in there. Or am I misunderstanding that term?
Well, I mean, fault tolerance has to do with what's happening, right? So, like, when you're being abusive to your database, it should be okay. I was an Oracle DBA for a long time, as you mentioned. That is a database that doesn't want to be fault tolerant. When we installed those big, beautiful servers, as like Sun single rack servers, well, that was the most sacred part of our data center, right? And like, no one looked at that rack. Oh, don't look at the Oracle server, because if it goes down, our whole infrastructure is down.
Yeah.
That is not fault tolerant.
No.
So the fault tolerance of Cassandra is in just really based in the replication story and how it manages that. At no point will data not be replicated. And we talk about replication factor as a part of data modeling. And there's two things. There's replication factor and consistency level. And that really, knowing how those two things work, really make your fault tolerance work for you as a developer. So I'll give you an example. When you write data into the database with a replication factor of 3, that means that 3 of the replicas are going to have that data. And you can specify that consistency level. Like, I want this at a quorum level, meaning at 51% acknowledge the write to disk. That's pretty solid. And that fault tolerance is, when you know that you're writing data into the database and you're getting a consistency level that you asked for, now you're ready for bad things. I ran in Amazon for the longest time. I ran production Cassandra for a long time, and I lost, availability zones. That happened a lot back in the day. And when a node goes offline, your application should not care. And the dance that we have between the Cassandra driver, and the cluster, the driver actually participates in the gossip. The gossip is a protocol for state in Cassandra. It's actually not only Cassandra that does this, but it's telling you the state of the cluster. And if it's like, well, this server is experiencing some sort of load problem, don't send a request to it. Or this server is no longer available, don't send any requests to it. These other two will handle it just fine. And it opens up the door for a lot of really interesting things, like, and now I can reboot my servers in the middle of day in production. And so it's not just bad things can happen. Now I can do things to my cluster and not have to do it at 3 a.m. on a Saturday.
Nice. So we've got decentralized and durable. I think you touched on it previously, which was about the different nodes. So is that sharding up your data set into these different nodes and pushing it out to different places, and the fact that not every node is a replication of the entire data set?
Yeah, that's just it. And yeah, with a replication factor of say 3, that means that every node will have its data plus 2 other nodes of data. So it's a linear scale at that point. It's not an exponential. So if you had a 4-node cluster, each node is going to have it and 2 other nodes worth of data. If you have a 1,000-node cluster, each node is going to have it and 2 other nodes of data. So it doesn't explode your data set that way. So that's that decentralized part. But it also is in the way that, so it's just built into how Cassandra works. It understands that every single node is aware where all the data is in the cluster. And that goes back to this notion of how it works. The important part of a data model and Cassandra is in the partition key. That's when you create a primary key in your schema. You have a partition key and clustering columns as part of that primary key. The partition key is actually taken from from the driver and from the database. We use a consistent hashing algorithm. In this case, Murmur3. It creates a consistent hash, that 64-bit number that will always be there when you give it the same input. So that lets us do, and because it's randomized, allows us to place data into the cluster. And this is really hard to do without a diagram. I'm using my hands a lot right now.
Yeah.
But just knowing that this very simple way of doing replication like that. Now, it also means that whenever I ask for that partition key, the consistent hashing algorithm is going to give me an exact server and replica that data is on. So you get a really fast response rate, even with a 1,000-node cluster. It's not going to have to do a scan across 1,000 nodes. It's going to go, nope, I know exactly where to go. It's like a postcode. And
sure.
So, when you have this, you could build out these massive systems now in different fault zones and everything. And that durability, that consistency of when you say, I want a quorum, I want just one replica with this data, et cetera, the response from the server is, no, this is now committed to disk. It's not in memory. It's on disk. So if the power goes out, comes back online, you have your data.
Right. Okay. So if the say your data center goes down, surely if a data center is down and you're only in that one data center, if all your nodes are in there, you can't get to your data. It's down. It's down. You're pretty stuck then, aren't you?
Yeah, there is no magic. However, you bring up a really good point. Yeah, and this is, I think, this is the Achilles heel of a lot of quote unquote distributed databases, is where they limit their distribution. How distributed are you?
Yeah.
Yes, if you're in one data center and that data center goes offline, you're offline. But the trick is do more than one data center. In part of my career, I ran infrastructure. I don't think there was any period of time, a long period of time, where I didn't have a complete data center failure of some sort. Network, power, something. I ran data centers in the 2000s, and I had a bunch of leased rack space in Northern Virginia. It got hit by a tornado. I have never heard of a tornado in Northern Virginia. I just didn't even know it happened. And we got a phone call from AT&T, the provider, and they're like, our data center just got nailed by a tornado. We're trying to bring it back online. And of course, everything's red across it. Who's ready for that? I wasn't ready for that. Luckily, we had a different data center in Atlanta, and they didn't have a tornado that day. But you cannot rely on a single data center. You have 0% chance of uptime, 100% uptime if you're in one data center. So Cassandra, in the way that it works with that replication that I mentioned, that it is multi-data center built in from day zero. That is a big part of it. And if you look at some of the largest and probably more interesting distribution or deployments of Cassandra out there, this is like Apple, Netflix, Instagram, they're all multi-data center and they're active. Netflix has a great talk about how they do active, and they actually, they have the chaos monkeys that they run. We've talked about those.
Yeah.
They have one called Kong, which actually takes out an entire data center.
Right.
And they do that in production in the daytime. So
nice.
Yeah.
I still have cold sweats about that. Many years ago when Hyper-V just came out, I was running a small hosting company at that point. And just as Hyper-V went from beta to release, we had special permission from Microsoft to allow customers to use the beta in production. Everything went down, and it was like, well, what's happened? And what it turned out was that the internet had gone down. Yeah. The main connection into the UK had become damaged in the ocean, and it was just off for everybody. And it's like, well,
how do you plan for that?
Yeah. Nobody thought that this would ever happen. Being in one data center is always very scary because of that.
Well, in this case, an entire island. But that's one of the things that Cassandra was built around. I was like, I'm sure you've heard of CAP theorem, the consistency, availability, and partition. That's part of NoSQL. But because Cassandra's really optimized around this partition event, managing that really well, that's what makes these active scenarios possible. Like, if you had a data center in the UK and one in Poland, which, that's ING Bank, by the way, you could lose that. And your customers, one half of that, or one side or the other, isn't going to get compromised. They're both fine. And then whenever the link is restored, the database will merge and rectify itself. And that's almost magic.
Yeah. Is there a delay between that replication? Is it minimal delay? So say I've just written some data to node 1, and I know that's replicated to node 2 and 3, but node 1 goes down just as it's been written to node 1. Is that data lost, or would that have gone out at the same time to the other two nodes?
Well, the replication speed is based on physics. So how far away is it? If it's in a single data center, you're talking microseconds. If it's far away, you're talking tens of milliseconds. But the data center awareness that's built into Cassandra does create these partition boundaries. So we have in the consistency level I told you about, any developer can pick the consistency level that they want when they're writing or reading their data. And when you're writing your data, you may say, I only want a local quorum. So that'll be the fastest for them. But it doesn't mean it doesn't get replicated, but it may get replicated in quorum within a few microseconds in a local data center, and it'd take 70 milliseconds to replicate across the Atlantic.
Sure.
But it's just the guarantees. Now, if that part, if that link was cut, this is just built into how it works. Once it's restored, the database goes through an active repair session where it's like, okay, I need to rectify my data. And it's a very simple algorithm. It's last write wins.
Sure.
Timestamps.
Yep. Yeah. So are there specific use cases where you would consider using Cassandra over some other options, both SQL and NoSQL options? Is there like a case that this is definitely when you would use Cassandra?
Well, yeah, it's a general purpose database, but I think I think the guidance I give everyone is what's the most mission critical for your data. So putting Cassandra as close to your customers is a really good idea, because that's the database that is going to make you look great. The use cases around that are like banking right now. A lot of banks use Cassandra, probably most of them or all of them. The most famous case is like Monzo Bank, which uses all Cassandra.
Right.
And, I mentioned ING is also really vocal about their use. So because banking is like, no, we don't lose data, and no, we don't have downtime. It's a 24/7 operation. Loves it. Retail is another one. I think every retailer except Amazon is using Cassandra somewhere in their pipe. So the most mission critical stuff like transactions and shopping cart, that kind of thing, product catalog, sitting on Cassandra. Again, what's the part that makes you money? Let's not turn that off.
Yeah.
And IoT is another strong area just because of the way it scales. You can see, you can see how that might be useful in cases where you just don't know how much data you're going to get. And if the scaling factor is just adding more data or adding more nodes into your cluster, it's great for that kind of workload.
Sure. So we mentioned a couple of other NoSQL databases earlier. How does Cassandra compare to the likes of Cosmos and Couch and Mongo? And you mentioned Amazon there, so Dynamo. Why should we consider Cassandra over the others? Is it just because of the fault tolerance?
I would back way up. Is the Cosmos, the Dynamo. Well, those are cloud databases. That means you have to be using their cloud. Cassandra is being used in multiple clouds at the same time. And we like to say Cassandra will scale larger than one cloud. That's what Cosmos and Dynamo can't do. Would you like to use Dynamo in Azure? I'm sorry, you can't do that.
Yeah. It gets you away from the vendor lock-in.
Well, in the walled garden, it is a way to lock people in for sure. But then you just just use everything in Amazon until you're. This is a famous story that happened in the U.S. The CEO of Target, big retailer, announced that they are no longer going to allow any infrastructure in Amazon because they're a huge competitor, and they moved everything to Google. And luckily, they used Cassandra, so they were able to migrate all that data over, no problem. But I mean, that's a reality that we have to live in now. It's not just the technology choice; it's also who's competing against us.
Yeah.
But other databases like, you mentioned Mongo is one of them. Mongo is just a different type of use case. It's a document store, as we mentioned, which is perfectly fine for a lot of use cases. It doesn't scale the same way as Cassandra. We don't really run into each other, quote unquote, a lot, just because Mongo is one type of use case and one kind of scaling issue, and where people usually come to Cassandra for different reasons completely.
Sure. So at the start of the show, I'd said about my naivety with databases, because being a Microsoft developer, a database is just where you store your data. It's not that important, really, is it? Now I get shot and alienated half of the listener.
Yeah.
But
that's actually a good point, though, because it shouldn't matter that much. And this is actually my new mission. We may be able to talk about that later, but it shouldn't matter to you. You just want to get your data in and out in one piece.
Yeah. I've said that I've started looking at Postgres just as an alternative to using SQL Server. It was something I hadn't used before. I'd used MySQL, but I hadn't used Postgres. And Postgres had a plugin framework around it, and I thought, this is fantastic. It had Postgres, so it could turn your database into a Post-REST. Sorry, it could turn it into a REST API. I thought, this is great. So I got it all running locally. I thought, I wonder if I can host this in Azure or Azure. And they were like, yeah, you can. Great. Can I add the plugins? No, it's all vanilla. So I couldn't do that. But that plugin framework was pretty cool. Is there anything like that for Cassandra?
We don't do. I know I'm familiar with the Postgres plugins, and it's a really interesting architecture how they built that. And it doesn't exist in that form in Cassandra yet. It's actually a very interesting discussion on the mailing list and in the project right now. If anyone wants to participate in the Cassandra project, we would love for your participation. But building more of a plugin pluggable architecture into Cassandra right now. There are ways you can do it. I mean, there's projects out there that, for instance, add Solr or Elasticsearch into Cassandra. That again, those aren't pluggable, but they're integrations that work with it. But yeah, I think Postgres plugin framework is probably the most interesting and advanced right now, for sure.
Sure. So we've talked about Cassandra being available both on-prem, and we touched on being in the cloud, and you're saying about Target migrating. So Cassandra is available on all of the big cloud providers. Then I guess
you have choices. You can do it yourself. You can go
yep.
go to cassandra.apache.org, download a tarball, and have fun. There's AMIs, there's cloud images. It's on every single cloud out there. And the interesting thing is, because it's really agnostic, it doesn't care. We do have, like, Sky UK is has great talk about how they have on-prem, and they're also in Amazon, and they're also in Google. So they do 3 different data centers, and they use Cassandra. What was really cool about the use case in that world is their developers, like you just said, they don't care. They use APIs on their microservices, and it all gets persisted down into a Cassandra layer that's replicating across those 3. So yeah, it's totally doable and done every single day. But now what we're doing at DataStax is we're trying to make that a lot more of an easy choice for developers with Astra. So we have DataStax Astra is a Cassandra as a service. It's supported now Google and Amazon, Azure soon. We'll have other clouds that we'll be supporting soon. But we're looking at, like, the future of hybrid database is just kind of a low threshold choice. You just, that's the easy way to do it. And if you want to use the open source version, that's fine too. So everything we do is going to be in open source.
Sure. So because Cassandra is open source, are the cloud providers implementing the main build of it, or are they tweaking it? Are they adding their own twist to it? Are there going to be any gotchas between? I've currently run my application in GCP, and now I'm going to put a version of it in Azure, but I can't do it in Azure because I'm using a GCP specific function in Cassandra.
No, because this is why we're really pushing hard at everything should be in the open source project. There are versions out there. For instance, Amazon has a version of Cassandra. Microsoft has a version that actually runs on top of Cosmos. They exist. And those are just compatibility layers. They give you CQL compatibility, and what I would say is if you want the full experience, get the full thing. Don't go buy a knockoff, get the full thing. And it's free to use. It's Apache Cassandra. And DataStax, our goal is to do the best job we can to make Apache Cassandra the most usable database in the world. And we will find ways to make money in various ways, like as a service. We do services and consulting, all these things. But mission one is Cassandra, the open source database, is just the top. That is the best version of Cassandra you can use.
Yep. Yeah. I think one of the things that you touched on previously was about Cassandra as a service. As a developer, that really, really appeals to me, because there's always been that hard trade-off between I'm the developer developing the application, but I want the DBAs and the DBDs to go off and do the database stuff. But I'm going to have to work really closely with them for this reason and that reason. Whereas with these APIs, I guess I can go, well, I'm just going to use this API. They can go and put the database wherever they want. They can do whatever they like. And as long as I get my data out, I don't care. And it helps to bring in that separation between those two roles or multiple roles, I guess.
Oh, you are you're singing my song. This is where I'm at now, especially in the project. So I actually spend a lot of my time in cloud native world too, like with Kubernetes. I'm a part of the TOC for CNCF, and this is the next 10 years of Cassandra. Is no longer sadly is to retire CQL completely. And why? What would be the choice? Well, getting back to what's useful for a developer, which means things like REST, GraphQL. I really love what GraphQL is doing and where it's going. It's so much more usable for front-end developers and even some back-end developers. But it's eliminating the need to learn another dialect of CQL or SQL or something like that. It's actually putting something in terms where developers can use it now. But this is all things that are coming to Cassandra. And you can start seeing some of those. We're doing some early things in our as a service. We have GraphQL and REST endpoints there. We're playing around with how they work. But the world that I want to live in, and this is what we're pushing really hard towards, is that the data modeling and having to deal with the backend, like developers touching a backend database, those days should be over. You should be able to express your code, write your code, and know that the database will just pick it up and run with it, and you're okay.
Yeah, that'd be absolutely fantastic. Because I could carry on being naive to the database, just get, it's my data store, I don't care.
Well, one of the things that we're doing right now is we have a product coming out soon. It's called Vector, but it's our first shot at bringing AI into operations, lowering the bar for running, like making decisions, changing things somewhat automatically. Right now, our first version is much like a self-driving car. Like, it doesn't take off and take you off to, see grandma.
Yep.
Right now, it's giving you assistance. It's like, you're driving off the road. Could you not do that? But we see the future in AI ops, especially with really complex distributed systems like Cassandra. That's key to success for developers, is knowing that whenever you put your data in there, it'll figure out what to do.
Yeah, I've spoken to a couple of different database people, shall we say, and they've got different products that are they've got smart indexing and intelligent indexing and all these different things where you don't have to think about it. You give it the data, it just goes off and it just does its thing, which sounds really good. But with that, it's the quote: with great power comes great responsibility, and if it ever indexes the wrong thing, then you could be in trouble.
Oh yeah, I think we've all been burned by like ORMs like Hibernate. Or why did you do that to my data? I don't want that anymore.
Yeah. Why did you say that execution plan? That's the worst one you could possibly have come up with. Go away, think about it, and come back when you have a better one.
Yeah, you should feel shame. Go sit in the corner. It's that lack of control, but that's why we're starting out in a kind of a light touch way. Is here, let's keep you from driving off a cliff. That's a good start. Instead of, here, we know better. Give me the code. I know what I'm doing. That will come, and that trust factor has to be built. What I worry about is that the world of development will be infinitely more complex if we don't have it. You mentioned serverless. We talked about edge. All these ways of let's just get down to it. Developers probably want their stuff to be used by the most people, and that requires that technology to be there. Like, edge is the way that it makes it responsive and interesting, but it's super hard because that means it's distributed into 2,000 different points of presence. Well, I don't want to think about that as a developer. I just want it to work.
Yeah, definitely. Now, we talked about 10 years in the future, 5 years in the future for Cassandra, but we're on the edge of Cassandra 4.0. What's new for Cassandra with version 4?
Yeah, so we're in 4 beta right now. So if you're using Cassandra, please go download and try it out. We need more eyeballs on it, as always. But I think that the key part of what Cassandra 4 is, and this is just because it's an open source database, it's not driven by the sexy feature that everyone's like, ooh, like this is the one thing, right? It's not driven by marketing. It's driven by actual practitioners. So it's been a while since we've had a major release. And the reasons is because we've had some of our largest users doing some pretty complicated testing and stability testing, like replaying entire workloads. And if one bit is missing, then go back and find out why. We just put a blog post on the Apache website. We're making a very bold claim, but one that I think will hold up, is this will be the most stable database you'll ever use. That's the first thing that we want. That's the first principle for this database. Because so much of the world is running on it and relies on it. If you're picking up a cell phone right now and using it, or you're listening to this on a device that has a screen, more than likely Cassandra's in the play somewhere. So yeah, you want that. There's a few other features that are pretty important, but around speed, we have some pretty significant speed ups, probably about 5x on a lot of transactions. one of the things that we're struggling with right now, especially in like a Kubernetes world, is the elasticity of a cluster. Scaling is, yes, I can go from 0 to 1,000. Yes, I can do that. Elasticity is I can go from 1,000 to 500. And that is much more of that's a harder problem, but also more relevant in the next few years, because people have events, organizations have events, a Black Friday, Cyber Monday, whatever, Boxing Day. All these events come up, or something happened like a pandemic. I don't know what happened, but anyway,
Yeah.
who knew that was coming? But
Yeah.
but when it's done, we want to scale back because we don't want to spend all that money on the infrastructure.
Yeah.
So these are some of the things that we're working through. I mean, really, getting 4.0 out there is a big deal because we've already started talking about 5.0.
Nice. It's good. So, with it being a major release, is there an upgrade path that people that are using a previous previous major release are going to have to go on, or is it download the files and away you go?
It's just if you're familiar with Cassandra, we have this idea of the rolling upgrade, which is a zero downtime upgrade. So if you have 10 nodes, then you just do one at a time. Where I think that we're going to be able to support an unmanaged upgrade from all the way back to 2.1. Well, just watch the blog whenever this finally gets released, but I think this is where we're going to settle in, because 2.1 is very popular for a lot of reasons, because it was a very stable release, first of all, and it had enough features, it's good enough. But most people are probably running version 3, like 3.11. 3.11 is very popular as well, but that'll just be a straight up upgrade. There'll be guidance in the changes.txt file about, in the release notes, like what you would need to do, if anything. But that is a big deal for us. Part of that stability factor is when you upgrade, it should not bring down your database.
Yeah, to be able to see that would be fantastic.
We have
good.
We have some people out there that are actually trying. I don't know. Their source of pride is their uptime right now. Like, we have some organizations that have had their Cassandra cluster up for years, and they're really, now it's like, well, we don't want to have any downtime because it will break the streak.
Yeah.
Like, what?
We'll have to reset that clock in the office.
Yeah, exactly. 0 days since an uptime guarantee. So no, there's who was it? I can't remember who it was. They have a cluster that's been on for 6 years now. Right. Never had a second of downtime. And
it's definitely not running on Windows then, isn't
it? It's probably running on like Arch Linux or something really oddball, that some admin is like, no, this is the only database operating system in the world. Yeah.
Awesome. So we're almost out of time. Let's just round this up with, for those that are out there listening that don't know really much about Cassandra, they want to get started with it, where would you direct them? What would be their starting point?
Well, I mean, first and foremost, cassandra.apache.org. That's the project. That's where we live. And if you want to know more about our Cassandra as a service or data stacks, we have great resources for developers right now. So datastacks.com/dev. If you're a developer, you want to learn how to use Cassandra, we have tons and tons of resources, examples. We're using Katacoda now, which if you haven't tried, it's really cool. And we're using Gitpod for some of our stuff. So a lot of hands-on there. And Astra, if you want to just give it a try, we have a free account. Like, you can get a free instance of Cassandra for life, limited, of course. But yeah, if you want to just give it a try and not have to download anything, Astra is a really good choice.
Awesome. So we'll include all the links to those in the show notes, so people don't have to quickly scribble them down. But that just leaves me with to thank you for coming on and talking to us about Cassandra today.
Oh, absolutely. And thanks, James, for having me and asking me those really hard questions, the cynical questions. Why would I do that?
Yeah, it's been good. It's been good. It's really interesting, and as I said, I'm a bit naive to database stuff. Sometimes on purpose, and just seeing what the other side of the coin holds is really good. It gives me some more strings to my bow when I'm looking at solutions for clients and for projects. It's really, really enlightening.
Oh yeah,
so, thank you.
Well, if you go give it a try, and if you find yourself stuck, you know where to find me.
Yeah, definitely will. Thank you very much. And thank you to everyone out there that's listening. Thank you for listening to The Cynical Developer. I'm James Stoddart, and you've been listening to Patrick McFadden talking about Cassandra. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help The Cynical Developer to reach more developers around the globe.